All right, this is part 3 of our review of exponential functions. In the last video, we graphed these functions. So if you missed that, go back and check it out. But in this video, we're going to talk about transformations, and then we'll do a little practice with rate of change. So when they say explain how the graph of g can be obtained from the graph of f, they're just asking for the transformations from the parent function. In other words, for example, this -5 right here, that's going to be a shift to the right 5, all right? That's the opposite of what you would normally think, so to the right 5. Okay? Looking at this 3, all right, if you look at the 3, sort of ignoring the negative sign for a minute, because that's a separate transformation, this 3 is a vertical stretch by a factor of 3. Vertical stretch by a factor of 3. Okay? And then the negative sign is its own transformation. All right? Having a negative sign in front like that is a reflection over the x-axis. Okay? So let's just do number 14 together real quick, piece by piece. So what about this 4/3 in the front? What's that going to do?
It's going to be a vertical stretch by a factor of 4/3.
Correct. This is a vertical stretch by a factor of 4/3. It's a fraction. Why isn't this a compression? I thought...
Because e is greater than 1.
Oh, see how it's an improper fraction with a bigger number in the top? That means it's bigger than 1. That's why it's going to be a stretch. So, vertical stretch by a factor of 4/3. All right, what other transformation do you see?
Down 9.
Yeah, down 9 because of this k value. Down 9. Anything else? I think that was it. Only 2 transformations on that one. Okay, let's take a look at number 15. Okay, 1, 2, 3. I see 4 transformations on this one. Mr. Wilson. No, not Mr. Wilson. Leroy. What does this -1 in the front do? Reflection, okay? That negative in the front is a reflection over the x-axis. Okay? So that's one transformation. Now the 1/2 is a different transformation. Okay? Sort of ignoring the negative sign, the 1/2 is its own transformation. What am I going to say about the 1/2?
It's a vertical compression by 1/2.
That is a vertical compression.
Is there like a horizontal compression?
Yeah, but we're not going to worry about that.
How does that look?
If it was, if there was a number bigger than 1, like inside the parentheses, just don't even, don't confuse yourself. Because technically it might have to be in this. Let's not go there for this type of function. It's jumping. Okay, so we have a vertical compression. By a factor of 1/2. What about this -7? What's that going to do?
Right 7.
Right 7. Okay, and what about the 1/3?
It's up 1/3.
Yes, it's going to be up 1/3. Okay. All right, so for the rate of change, that's just a fancy way of saying slope. So the easiest thing to do is to make yourself a table of values and use it to find the slope. When they give you this interval, 1, 2, they're giving you x values. These are both x values, okay? x1 and x2. So there's my 1 and my 2 are x values. So I need to find the y values that go with those x values, and I'll find that by plugging them into the formula. So if I put in a 1, then that's 5 to the 1 power minus 2. Well, that's just 5 minus 2, so that's just going to be 3. So I have the 0.1, 3. Okay? If I want to do the next one, I'm plugging in 2. So that'll be 5 to the 2nd power minus 2. So that's 25 minus 2. So that's 23. So I have 2, 23. Any questions so far?
No.
Okay. So now I'm just going to find the rate of change. I'm just going to find the slope. I need to erase this to make space. Whoa. So to find the rate of change, we're just finding the slope. So that's y minus y over x minus x. So that's going to be 23 minus 3 over 2 minus 1. So that's going to be 20 over 1, which equals 20. So that's going to be the rate of change. Any questions on number 16? Okay. Number 17 is basically the same thing. I'm just going to roll straight into it. So once again, x, y. It says we're finding the rate of change of this function from 0 to 3. So that means my x values are 0 and 3. So if I put in 0, so that's 3 times 2 to the 0 power. So that's just 3 minus 2, which is 1. And then now I'm going to do the 3. So that's 3 times 2 to the 3rd power. So that's 3 times 8. So that's 24 minus 2. So that's 22. Okay. Does everybody agree on those 2 points? Any questions? Okay. All right. So I need to erase this to make room. So hopefully it'll let me do it this time. Okay, so now we'll do the rate of change. Again, it's just the slope. So y minus y over x minus x. So that's 22 minus 1 over 3 minus 0. So that's 21 over 3. So that is 7. So that's our rate of change. Any questions about that? Question. So one more time, rate of change. This time they gave us no equation, but that's fine because they gave us the table already. So they say day 1 to day 3. I'm still going to make a little table of values of my own because I don't like theirs. I'm going to make my own. Okay. They said 1 to 3. So there's the 1, there's the 3. So what's the y value that goes with the 1? 1? Okay, where am I getting that from? From the table. 1, 1. I just got that right there. And what's the y value that goes with this 3? 9?
Yes.
Okay, because I got 3, 9 from the table.
Yeah.
And the rest is the same. So I need to go. So for the rate of change, I'm doing y minus y over x minus x. So that's going to be 9 minus 1 over 3 minus 1. So that's going to be 8 over 2, which is 4. So that's the rate of change. Any questions on number 18?
No, sir.
Okay, let's see where we go from here so I can tell if I need to change the video or not. Alright, this is a relatively short video, but I'm going to go ahead and stop this here because on the next video we're going to go into all this solving, and there's plenty of those to fill up a video. Alright, so see you on the next video.